Hello viewers, in this video we are going to see how to fine-tune a Mistral7B model for a classification task. As you all know, Mistral7B is a large language model, open source, developed by Mistral AI, which outperforms Llama 2 13 billion model, and then it's competitive with Llama 2 70 billion model. So let's see how to use this Mistral 7 billion model for a campus recruitment prediction task. So campus recruitment prediction is a classification task which takes students' information from a given university, their CGPA, their number of internships, their number of projects, and then the marks attained by the student in various exams, and then the output category is placed or not placed for the given student. So this is the standard CSV dataset which we have, which has a various features, and then the value of the student in the particular feature, and then the output category is placed or not placed. So in the traditional machine learning, we can use the same data set for the training and then testing and validation, as the machine learning algorithms like decision trees, support vector machine accept the vector of inputs as a vector as an input, and then it will give the 0 or 1 prediction as an output. But the large language models cannot accept the vector as an input. The large language models are pre-trained on text-based data, so we need to convert the CSV data into a text dataset so that we can use the text dataset to fine-tune the model. So that requires an intermediate step. So here I use the Mistral7B model to convert the given data into a text format. So I loaded the Mistral 7 billion model from the Hugging Face, given a prompt, and then it gives the output. Just testing the model and then loading the CSV dataset from the Hugging Face. So we have the 7000 training rows and then 1200 validation size, and then the test size goes around 1500. So for a given student, we have CGPA, number of internships, projects, number of workshops, the marks of the student, the rating, and then we have all this information, and then the output label is the placement status. So to convert the given data into text, we are using in-context learning with zero-shot fashion. We are giving the instructions to the LLM to convert the given row information of a student into a text. So let's say we are giving these particular details of a student into the model. The model assumes a name and then describes the given information in JSON as a text. So it explains like the student has 7.7 GPA with strong performance, and then he has one internship and one project. So this is the sample. Now we are going to run the same pipeline for all the splits, the train, text, and validation for all the example rows. Now after the model generates the text for each of the student, we are going to convert it to a new data set called as campus recruitment text. Now we can use this particular text for as an input to the LLM, and then we have this label which is placed or not placed. So this is the typical data set which can be used to fine tune a large language model for classification task. I used Kaggle to fine tune the Mistral 7 billion model on LoRa configuration. So LoRa is a low rank adaptation matrix. So it only uses fewer parameters to fine tune the large language model, and then which requires only less GPU, and then it's faster compared to the fine tuning all the parameters of the large language model. Since P100 is a GPU which comes free for all Kaggle users, we can use the P100 GPU to do this task. So I loaded the same dataset, the text dataset from Kaggle, and then we are loading the Mistral7B model in a 4-bit quantized way. So this is the sample input. We have the text about the student, and then we have the output label. So this is the distribution of length of the response, the information about the student. We have this. So this is the number of tokens which goes around. So the average is around 200 input tokens. So this is the LoRa configurations. So you can tune the parameters, what are the modules you want to change, what are the parameters which you want to introduce, and then the alpha, and then the rank of the LoRa configuration. Now we just changed our model into a PEF model, and then this is the number of parameter which we are going to change, where this is the all parameters which are available in the Mistral7B. So as you can see, we have only fine tuning 4% of the original size. So this is the prompt which we are used for fine tuning the model. So we are giving instructions, classify the student into placed or non-placed based on his or her college report details, right? So we have the report of a particular student, and then we have the label. So we are going to fine tune the model to predict this particular label given this particular information. So these are the training arguments. We have the standard training arguments of setting the learning rate, the train batch size, and then the evaluation batch size, and then the number of epoch. So as you can see, the loss is decreasing, and then once the model trains, you can save the model in Hugging Face, and then you can use the model for the inference. So during the inference, you can pass any report of a student which is not there in the training dataset. You can pass there in the as a prompt to the model, and then the model will give the correct label as placed or not placed. Thanks for watching the video. Feel free to comment your questions and like the video if you found anything useful. Thank you.